Hi, Team 6 here. So, this presentation uh, tries to explain how we selected and optimize a machine learning algorithm to predict the recent cannabis use using the UCI drug consumption dataset. The objective of this assignment was to implement a supervised classification model and determine which algorithm maximizes predictive accuracy while maintaining strong generalization performance. So as we can see from our notebook, we began by importing our libraries and loading our data set. Then we went through the EDA, just checking our data to know what consists our data set. We loaded our data and checked the DF head. Then we went on to check the DF info and also checking the missing values. Our data doesn't have any missing values. Then we it took a step. Our data set consists of many drugs, but we narrowed our analysis to only a cannabis, which then became our Y variable. Despite that, the cannabis was imputed on an ordinal scale of 0 to 6. We turned this into a binary representation that is from the point of 0 to 2, we say those are non-recent users, and then from 3 to 6, we said those are recent users. So it was important for us to balance this scale so that all the information is represented by balancing the classes to prevent inflated accuracy caused by majority class dominance and ensure fair evaluation of model performance.
Okay, so for the next step, to ensure proper modeling, we implemented a pre-processing pipeline where categorical variables were one hot encoded and numerical features were scaled where appropriate. These pre-processing steps were integrated into a scikit-learn pipeline. Using the pipeline is critical because it prevents data leakage, ensures transformations are applied consistently, and allows fair cross-validation. So we then split the data into training and testing sets using a stratified sampling to preserve class proportions.
Several classification algorithms are compared to determine which one gives the highest accuracy. The model tested were logistic regression, linear support vector machines, random forest, extra trees, and histogram gradient boosting. Instead of using a single train test split, a stratified fold cross-validation with 5 folds was used. This method is more reliable because it ensures each model is a balanced distribution of cannabis users and non-users. The model comparison step outputs the mean cross-validation accuracy of each classifier, and the highest model with mean accuracy will be selected. Imported libraries from sklearn, define the train test split, and also define the stratified k-fold with 5 splits. We have also defined the models. This code will give us the results. As we can see from the cross-validation accuracy results, linear, as we see, is the highest percentage of 81.6%. The next step that we did was to do hyperparameter tuning across multiple models to improve accuracy, and we have used randomized search CV. This ensures a fair comparison of model after optimization rather than relying on the default parameters. The tuned model with the highest mean cross-validation will be selected. We have defined the randomized CV that will do the parameter search from the model that we have defined. Now we're defining the parameters that are going to be searched by the randomized CV. And then we summarize the results, and as we can see, random forest is 82.03%, which is the highest model accuracy. We have generated a configuration matrix and a classification report, and an accuracy of 80%. The base parameters that were used by the randomized search CV, they are shown here. After hyperparameter tuning, across all candidate algorithms, random forest achieved the highest cross-validation accuracy of 82% and was selected as the final model. When evaluated using unseen dataset, the tuned random forest achieved a test accuracy of 80%, demonstrating strong generalization performance. The confusion matrix indicate balanced predictive performance across both cases with similar precision and recall for a non-recent user with an F1 of 0.79 and a recent user F1 score of 0.81.
To conclude, this project used the UCI drug consumption dataset, which included demographic and personality features for 1885 individuals. The model was designed to predict whether an individual is a recent cannabis user or a non-recent user, based on their demographic characteristics and personality traits. To achieve this, multiple algorithms were evaluated using a stratified 5-fold cross-validation, and selection was based strictly on empirical accuracy rather than assumption. After hyperparameter tuning, the random forest classifier achieved the highest validated accuracy and demonstrated strong generalization on unseen test data. Accuracy was improved through careful target engineering, proper pre-processing using a pipeline to prevent data leakage, and systematic hyperparameter optimization. The final model produced balanced precision and recall across both classes, indicating stable performance. In a real-world context, this framework could support public health analytics and behavioral risk assessment by identifying patterns associated with substance use. Overall, the project demonstrates a structured, evidence-based approach to machine learning, model selection, and optimization. Thank you.